Hi everyone, it's Mrs. Brimlow, and today we're going to look at the difference between linear and nonlinear functions in graphs and equations. So we're going to do a little investigation first and then read through some notes together. So if you could turn to page 36 in your packet or click on the link provided with a copy of the notes, we can go ahead and get started. You're also going to notice linked in Canvas is Desmos, which is a graphing calculator. So if you'd like to try and use Desmos on your own and go through this investigation, you can, or just follow along with me. So Desmos is a graphing calculator, which makes our lives a little bit easier than trying to find coordinates then graph them, especially with ones that might not be linear. So we're going to graph the linear equations on Desmos and also nonlinear. We're going to fill in each table with 5 points from the line. We're going to sketch it as best we can on our graphs for what space we have, and describe any observations you have about the graphs based on the lines provided. Okay. All right. So the first one is y equals x squared. So whenever you're trying to type in an exponent, you want to hit Shift 6 at the same time, and you'll notice it's going to raise up. So that's x squared. So I'm going to zoom in a little bit so that we have 1. I'm going to get a couple of coordinates on this side as well as this side. So I always like to start with -2. So in my table right here, okay, so when x is -2, looks like y is -4. Yep, it's hard to sometimes get it exact, but oh, I had it. But I can see -2 is at +4. So when I'm at -1, I get an output value of +1. 0 is 0. 1, I get 1. And then 2, I get an output of 4. Okay. So then I'm just going to kind of sketch this on my graph. And I'm going to use the points I have to help me, since they will fit right here. So you can see this has a curve to it, and it kind of looks like the letter U. This keeps going on and on forever. So shaped like a U, so it has a curve, meaning that it is nonlinear. The word linear means that it's a straight line. So by saying it's nonlinear, we're saying it's not a straight line. So this would be our first example of a nonlinear function. Okay. All right. So now I'm going back to Desmos. I'm going to go ahead and backspace it. And up here, I'm going to write y equals negative. So for a fraction, you're going to do 3 and then slash and then 2. Now you want to make sure you either click next to the fraction or use your right arrow key, because then it will continue writing the fraction underneath, or the function underneath the fraction bar. So then we have x minus 4. All right, so I'm going to use -2 again. So -2, I have an output of -1. -1 is kind of in the middle. So let's go ahead and use 0. And I have -4. Same thing with +1. So 2 is at -7. Zoom out. Let's see. -4 is at +2. And +4 is at -10. Okay. So now I'm going to kind of sketch this on my graph a little bit for as many coordinates as I can fit. So 0, -4, -2, -1. Let's see, -4 up 2. And can I fit 2 -7? 1, 2, 3, 4. Yes, I can. All right. So I'm going to do my best. Draw it. So this is an example of a linear function. So this is linear. It has a negative slope. I also know that this is linear because it's in the form of y equals mx plus b. Okay. So if you start comparing these equations and what's different about this compared to this, what makes this linear versus this one nonlinear? So I see they both have y equals, they both have x. This has a -4, but what makes it different is this has an exponent in the equation. So whenever we have exponents in our equations, it's going to mean that it's going to be nonlinear. So we already should know just by looking at this equation, this is not going to be linear. So this is going to be nonlinear. But what is it going to look like? Let's go ahead and graph this. So y equals x to the third. So you can see here, whoops, I'm going to just reset it. Just click on the home. So it's got a little bit of a curve to it, making it nonlinear right here at 0. So a couple points here. I've got 0, 0. I've got 1, 1. I've got -1, -1. 2 is going all the way up to here, 8, 2, 8. And then -2 is down here at right here about -8. Oh, I always struggle to get right on the, right here, -2, -8. Okay, so I'm going to graph this as best I can. So I've got 0, 0, 1, 1, -1, -1, and then 2 is going to -2, -8's off a little bit, and then it's going to be a little off here. So I can see this is nonlinear. There's no specific shape to it, but I can see where it curves in the middle, okay? And it has an exponent in the equation, okay? All right, so last but not least, we have y equals. Now, these bars are absolute value, which you studied last year at the very beginning of 7th grade. And absolute value is the distance from 0. So, for example, the absolute value of 3 would be 3 because 3 is 3 units away from 0. However, the absolute value of -3 is also 3 because it's 3 spaces away or 3 jumps away from 0 on a number line. So absolute value is always positive unless there's a negative sign outside of the bars in front, and it's talking about distance. So how do you type this in when you're working with your when you're working with Desmos? So you're going to notice down here in the bottom left corner, they have a little keyboard symbol. And I'm just going to move this. So right here, they have the bars around A. So that's how you'll type in the absolute value. So y equals, click the absolute value bar, and then it's going to allow you to type in your function. And when you're done, you just click outside of it. So I'm going to do that one more time. So down here, I'm going to click the keyboard button, bottom left. I'm going to start typing my function y equals. I click on here where it says absolute value of A and then type my function in the middle. When I'm all set, I click outside of it and then I press the space bar once. So this is the absolute value, or y equals the absolute value of x minus 3. This is the graph for that. So I'm going to go ahead and write down a couple of coordinates. And I'm going to start here where I see 0, 3, my y-intercept, just because that will give me a better picture of what this function looks like. So 0, 3, 1, 2, 2, 1, 3, 0, 4, 1. And I'm going to graph this as best I can on my graph. And I actually included more points on my graph that what I saw on, sorry, it's for my recording, than what I saw, just so I could have a nice visual. So this is shaped like the letter V. That's what I think of. Shaped like V. Now, even though it's made up of 2 lines, this is not considered linear because right here it turns and goes in the opposite direction. Linear needs to be going in the same direction from left to right, whether it's going down, it's going up, it's staying horizontal, okay? So this changes directions, and this is non-linear. So this is non-linear, okay? So basically what makes a function linear is moving at the same constant rate. And if you could actually turn to the page 39 in your packet, I have this really nice graphic organizer describing what it looks like in all settings. So linear versus nonlinear. This side is linear, this side is nonlinear. So in a graph, it's going to be a straight line in one direction only, from left to right. Here it could be curved, or it might go in a different direction. We didn't talk about tables, and we're not really going to focus on that this year, but in a linear function, it has a constant rate of change, so it has the same ratio when simplified, whereas it's not constant here, 3/1, then 6/1. That's not going to simplify to be the same. If this was a 2, that would be different, because 6/2 is the same as 3/1. But since it's 6/1 and it changes, it's not a constant rate. So we wouldn't say that this is it wouldn't look like a straight line when we graphed it. And then when we're in the form of an equation, so once again, equations typically have, this is what we call slope-intercept form. Now, there are other forms of linear functions we didn't study this year that you'll look at next year. For example, this right here is what we call standard form, and there's another one called point slope form. Okay, and equations that will form curves, you're going to notice they have your exponents, or it could have some sort of operator such as absolute value being included with it that will make it so it's not a straight line from left to right going in the same direction. So for practice today, you're going to look at linear versus nonlinear. There's a practice sheet here, page 38. Also a great IXL strand I would highly suggest practicing, linked below on Canvas. So you're going to do that today, and then we'll be getting ready for your assessment the rest of this week. If you have questions, please reach out.